Summer often promises the crisp, honeyed flavor of a perfect cantaloupe, but the reality is frequently different. Too many of us have brought home a melon only to find the flesh is crunchy, pale, and remarkably bland. That disappointment comes with a literal price tag. Families routinely spend over $100 a season on melons, yet a significant portion of that investment ends up in the compost bin because the fruit simply lacks flavor. This isn't a new problem. For decades, consumers have navigated produce aisles like this one, participating in a blind selection process where luck matters more than logic. In the modern grocery store, you are essentially playing a losing lottery, paying full price for a fruit that might only deliver a fraction of its intended sweetness. This chart measures Brix, the percentage of sugar in the fruit. While a standard supermarket melon might struggle to reach double digits, specialty varieties like El Gordo or Ambrosia can hit 16%, a sugar concentration that rivals wine grapes. That massive gap in sugar isn't just a matter of luck or variety. While genetics provide the potential, the actual sugar content is a direct result of how the plant interacted with its environment. Think of a sweet melon as a biological solar battery. The reason store-bought fruit often tastes like water is that the battery was unplugged from the vine before it had time to fully charge. To find the best fruit, you have to learn how to look at a melon and see a physical record of the sky it grew under. Certain varieties are bred to be super sweet, but that thick orange flesh won't actually develop its signature flavor without the right conditions. Genetics provide the blueprint, but nature provides the fuel. A melon vine needs at least 6 hours of unshaded, direct sunlight every single day to actually manufacture the sugar levels its DNA makes possible. During development, light serves as the catalyst for the plant's internal machinery, driving the synthesis of the sugars that eventually concentrate in the fruit. When the sun is blocked or the days are too short, that process stalls. Less sunlight translates directly into less sugar and a slower overall ripening process. The environment leaves physical marks on the fruit. Take the tiger melon. The intensity of the jagged red markings on its rind records the temperature. Cooler nights cause these patterns to darken, while warm nights keep the color soft. Every melon is a living ledger. Its internal sweetness and its external appearance are the direct results of the weather it experienced while it was still connected to its power source. But creating that sugar through sunlight is only one part of the process. So the melon to reach its peak, those sugars have to be concentrated. This happens through a final environmental trigger: water restriction. As the fruit nears ripening, reduced water intake allows the existing sugars to become more dense. Instead of those sugars being diluted by a high water volume, the melon becomes a concentrated reservoir of flavor. This is why gardeners aim to harvest on hot, dry afternoons. When the plant has the least amount of water in its system, the concentration of sugar in the fruit is at its absolute highest. Commercial agriculture often struggles with this timing. Large-scale operations prioritize yield and shipping logistics, meaning fruit is often harvested when it's convenient for the crew, not necessarily when the sugar concentration is at its peak. Real sweetness requires a specific sequence: intense solar input to build the sugar, and then dry conditions to condense it. So, how do you find the melon in the produce bin that actually completed this process? You must look for the fingerprints the vine and sun leave behind on the rind. Look at the stem end for what growers call a full slip. You want to see a clean, smooth, concave indent, a small bowl where the stem used to be. Biologically, this indent proves that the plant finished its job. The vine naturally formed a separation layer and let go of the fruit, signaling that the solar charging cycle was complete. If the stem is torn, rough, or still attached, it means the fruit was cut away by force. That melon was stopped mid-cycle, disconnected from its biological engine before it could reach its full potential. The stem end is essentially a receipt. It tells you exactly how much time the melon spent drawing energy from its source. Next, check the weight. A melon that matured fully is roughly 90% water and packed with dense sugars. If a melon feels heavy for its size, it's a strong sign that the internal tissues are well developed and full of juice. Finally, use your nose. If the blossom end is hard and there is no musky, floral perfume, the ripening process never reached the finish line. It's a harsh reality of the produce aisle. A cantaloupe will not get any sweeter once it's picked. While it may get softer over time, that's just structural decay. It will never gain more sugar than the moment it left the vine. Understanding this biology changes the way you shop. It moves you past the blind lottery of the produce aisle and gives you the tools to identify the specific fruits that actually spent their time in the sun.